My dear friends, welcome to Raja Sekar classes on applied data science with Python. This is lecture number 248. In this lecture, I will discuss about SNE with MNIST dataset. I request you to go through lecture number 221. Lecture number 221, in which I discussed about this particular MNIST data set. In this lecture, we will try to understand how SNE. In this lecture, we will try to understand how SNE works. How SNE works on this particular data set, that is MNIST data set. If you recall, MNIST is character data set. It is character data set. You can find digits from 0 to 9, isn't it? Each character has got 784 dimensions, isn't it? 784 dimensions, and we have 784 dimensional data which we are trying to project into these 784 dimensions. We are trying to project into 2 dimensions. That's what we did, isn't it? From 784 dimensions to 2 dimensional data. Anyway, just we will see that character data set once. This is 0. Just if you observe carefully, in this data set you have zeros, different types of zeros, isn't it? Even different types of one. There are straight ones, there are slanted ones. Just see, slanted one, straight one, slanted one, isn't it? You have different digits from 0 to 9, different types of digits. You can find different types of digits in this particular data set, isn't it? Now, we will try to understand. I will explain SNE plot. I will explain SNE plot of MNIST. We will try to understand SNE on MNIST dataset. I am referring this famous blog cola.github.io/posts/2014-10 visualizing MNIST. First, let me discuss this. SNE plot of MNIST in this PowerPoint slide. Then I will go to this particular blog and explain what's happening. Let me call I have 2 dimensions. Let me say this dimension is f1 dash and this dimension is f2 dash. After projection, this is final outcome, isn't it? I have got 2 dimensions, f1 dash and f2 dash. If you observe carefully here, this just see, these are zeros. This red points indicates zeros. All zeros are grouped together and all 6s are grouped together. All 1s are grouped together. All 2s are grouped together. All 5s. If you observe, you can write 5 in different manners. That's what I shown in data set. These are zeros. But this 5 is grouped with zeros. Why? Because this 5 is almost written like 0, isn't it? That I will show in this github.io, isn't it? Even you can find 5s here. Even just see these points. These points indicate 5s. This point indicates 5. Of course, this 5 is grouped with this one. These points indicates 1s. As I told you, all 1s. There are different types of 1s. These 1s are separated from 2s. Internally also these ones are grouped. There are different types of ones. Slanted ones. Internally slanted ones grouped together. Internally straight ones. Slanted one means something like this. Straight ones grouped together. That we will try to understand while visiting this particular cola.github. We can say this is, I already discussed about this blog. This is one of the best blog that I have come across, explaining these 2 techniques, 2 machine learning techniques, SNE and PCA. SNE and PCA, principal component analysis on MNIST on MNIST data set very beautiful, very beautifully, isn't it? Just go, we will visit this particular blog and we will try to understand. Here you must understand the spread of zeros are here. Just see, this is spread of zeros. Spread of zeros here. Spread of funds. This is spread of funds. Here you must understand. One must understand a very important point. We cannot interpret in TISNE. We cannot interpret cluster sizes and intercluster distances. We cannot interpret cluster sizes and intercluster distances in TISNE. I already discussed this in distill.pub. While discussing about outcomes of TISNE, we discussed this particular two concepts. This you must understand. What are those two important concepts? I cannot interpret cluster sizes. I cannot interpret intercluster distance. I cannot interpret this cluster size. 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 Even I cannot interpret the distance between these clusters. I cannot interpret. This distance also I cannot interpret. Since I can't visualize 784 dimensions, I have two-dimensional data. When I visualize in this two-dimensional data, first thing I noticed is all of my zeros are grouped together. Just see, all of my zeros are grouped together. All of my sixes are grouped together. Just see. Here, if you see, if you have all of fives, here I have fives, here also 5. But this 5, if you carefully observe, this 5 is grouped together zeros. Why? Because the way they have written this 5 is almost like 0. That's why that 5 is grouped together with zeros. Why it's grouping? Even we will discuss while we visit about in this particular blog, cola.github blog. After a few minutes, we will visit that one and we will try to understand. You must understand here is, it is not only separating all your ones from rest of characters. These are ones data. Not only separating ones from rest of characters, but also it's separating all your slanted ones. As I told you, you may have slanted one, you may have straight ones. This is slanted one, this is straight one. Slanted ones, in this all of your straight ones, all of straight ones are separated with the slanted ones. You can find in this particular region, slanted ones are grouped together. Slanted one means just like this one. Straight one means this. Internally also, they are separated with each other, which means whatever visually looks similar are getting grouped based on visual similarity. Here we are grouping in TISNE. We are grouping based on visual similarity, which is extremely important. What TISNE is achieving very successfully is, it is saying that I will group points or I will cluster points based on visual similarity. That's important. That's why slanted ones are grouped together, straight ones are grouped together. They're based on visual similarity, which is very interesting. Now using TISNE, I have visualized a 784 dimensional data set by embedding this data set into two-dimensional space successfully. And a big lesson I learned, points which are visually similar are grouped together, are close together. Points which are less similar are farther away. And if I color points by your actual class labels, whether it is 1, 0, 5, 6, just say 1 data points are grouped together, 0 data, 0 labels, 5 labels, 6 labels, isn't it? This tells me this tells me that in my 784 dimensional space, my points are visually grouped and I can easily build simple model. These zeros, ones, 5, 6, the data set is well separated. I can say like this, this data set is well separated, well separated. As this data set is well separated, they are well clustered, grouped together, and they are well separated from each other. They are well separated from each other, isn't it? So from this I will know that I can easily build simple machine learning model. As I have got well separated data set, I can build simple machine learning model on this particular data set. In future classes, we will run various machine learning algorithms as we learn on on this particular MNIST data set. We will try to run different machine learning algorithms. How we can do it, we will see in future classes. Time being, just let me go to this particular cola.github. As just see, if you observe carefully, these are my zeros. What is this? These are sixes, isn't it? This one is 2, but this 2 is grouped with zeros. What's the reason? The way they have written this 2 almost like zeros. That's why, as I told you, this SNE makes use visual similarity. They are grouped depending on, just these are ones, these are ones, but internally these ones are also clustered together, all slanted ones are together, all straight ones are together. I request you to run it again and again. Just go to this particular colas.github.io/post/2014-10 visualizing MNIST, so that you can understand. Just see this, as I told you, this 2 is grouped with zeros. In my PowerPoint presentation, I have shown that 5 is written just as SNE is a stochastic algorithm. It will generate slightly different outputs in each iteration. Why it generates slightly different outputs, that also I discussed in my previous lectures. I request you to go through my previous lectures so that you can understand. Just always try to just see these points, just see how beautifully they are visualizing. This is my 7, this is my 2, isn't it? This 2 is almost, as I told you, they are grouped depending on visual similarity. Just go through this lecture. If you have any difficulty, just keep a comment so that we will try to understand. If you have any difficulty, just you can keep a comment so that we will try to understand. Thank you very much.